Hello everyone, welcome back to the channel. I am Nikhil Kumar. In the last video, we have deployed the Gateway API using NGINX Gateway Fabric and routed traffic to our blue and green sample application over HTTP. Today, we are going to upgrade that setup to HTTPS. We are going to generate a self-signed TLS certificate, configure the gateway, update the HTTPRoute, and finally test the secure traffic end-to-end. This is the perfect foundational step before we move to an automated TLS using cert-manager in the next video. So let's get started.
Before we jump into the TLS, let me clear something that might confuse you all in the previous video. When we created a gateway, Kubernetes shows the service as a cluster IP, but somehow we are still able to access the app from outside the cluster. So what's going on here? So NGINX Gateway Fabric automatically creates a second service behind the scene. So if I run kubectl get service, we can see another service called TLS Gateway -nginx got created with a type called NodePort. And this service is being created by the NGINX Gateway Fabric. And if you notice this particular IP address, this is the same IP address which is being assigned to the gateway. So if I run kubectl get gateway, so this is the same IP address. We are getting it from this particular service. So inside the cluster, we can use the cluster IP, but to access this application outside the cluster, so we need to use this NodePort configuration. So how to access this particular application outside the cluster? So if I go to the browser and paste the IP address and the NodePort, so the NodePort is 31015. And if I hit enter, and the application is working fine outside the cluster, but we have set the path-based routing. So for that, let me give the path /green. Now we can access the application outside the cluster, and if I hit blue, so both the paths are working fine outside the cluster. So even though I connected with the browser with a node IP and the node port, so it's working fine. But within the cluster, we can use the cluster IP. And if I run this and the path, so this is working fine. So you will always see two things. The gateway resource is having the cluster IP, and behind the scenes, NGINX Gateway Fabric creates service with the NodePort type. That NodePort is a real entry point your browser or curl is hitting. So even though the gateway YAML shows cluster IP, the actual traffic flows to the auto-generated service, that is NodePort service.
Just a quick note, for internal testing, demos, and the home labs, the NodePort over HTTPS is completely fine. But in production, the recommended approach is use a proper load balancer, either from your cloud provider or a metal LB on your server. This gives you a stable IP, health checks, high availability, and a better security. NodePort can still be used in the production, but only if you have an external load balancer or reverse proxies pointed to your NodePorts. So for learning and testing purpose, NodePort is completely fine. But for the production use cases, the recommended approach is use an external load balancer.
Now let's start by creating the hostname that our certificate will use. So for that, I have already added this entry in the etc host file. But I will show you again so you can understand what it looks like. If I open this file, vi/etc host file, host, I think it's host. So in this, I have already added this entry. So this is the private IP of this particular server, and the hostname I am giving is master01.local. Similar thing I did for the public IP, and this is the hostname which I gave, that is master01.local. So basically, this doesn't change the Kubernetes node's real hostname. It simply creates a local DNS alias so that whenever I type master01.local, it resolves to my node's IP. Now the hostname is ready. So if I run ping against this, so it will go to this particular IP address, that is the private IP of this server. If I run IP space addr show, and if I go up, this is the same IP address that is being pinged by this particular host name. Now that hostname is ready, let's generate a TLS certificate. So for that, I am going to run an OpenSSL command to generate a certificate. So let me clear out the screen and run the OpenSSL command. So this command generates two files. One is the .crt, that is a certificate file, and another is .key, that is a private key file. So we will use these to enable HTTPS on the gateway. Now let's store this certificate inside the Kubernetes. So for that, we need to create a secret. So we can use the command kubectl create secret and the secret type, that is TLS, and I am giving a name that is demo-crt and giving a path of the CRT file, that is --crt equal to tls.crt. Similar to that, I want to give the private key. So for that, we can use --key equal to tls.key. So this command creates a secret for us with the CRT file and the key file. If I run kubectl get secret, we can see the secret got created with these two information. Now the secret got created. Let's update the gateway resource to use it. In our previous video, we have used this gateway file. So if I open this, in the previous video, this gateway only had a HTTP listener on port 80. So it was a plain HTTP. There is no TLS, no certificate. So similar to the HTTP, I need to add a block for the HTTPS. At the same level of the name, I need to add an entry for the HTTPS. So I'm giving a name HTTPS here and specifying the protocol that is HTTPS, and then I need to specify the port for the HTTPS request. So that is 443. Now the TLS configuration. So for that, it starts with a keyword called TLS, and specifying the mode, that is terminate, and I'm going to specify the certificate reference. So we just created a certificate secret, so we are going to reference that particular secret here itself. So here I'm going to specify the name, that is demo-crt, and the kind, that is secret. So it should be camel case. So the HTTP listener stays exactly the same. The only change I did is to create another block for the HTTPS request, and where I attached the TLS certificate information in a form of secret. So this tells the gateway to terminate the TLS on port 443 using the certificate we generated and stored in the secret. Now let me save this file and apply this. So kubectl apply -f NGINX Gateway.yml. So the gateway got configured. So if I run kubectl get gateway, so it still shows the ClusterIP. Now if I run kubectl get service, here something got changed. That is, this particular configuration got added. Earlier it was only showing the port 80, that is for the plain HTTP request. But now we just added the HTTPS block as well in the gateway. So it assigned another port which is for HTTPS request. So now this 443 node port is our HTTPS entry point. Now we only need to make a small update in the HTTP route, so the gateway knows which hostname these routes belong to. So now let's update the HTTP route. In the previous video, our HTTP route only had the paths like /green and /blue. So if I open this file, so these are the two rules which we created, that is for /green and /blue. So but for HTTPS, the gateway needs to know which domain these rules apply to. So we simply add the hostname here in this particular file. In production, you normally don't modify your HTTP route file for TLS. TLS already points to your load balancer. But in the lab environment like this, where we are using the NodePort and the /etc host file, adding the host name makes the route match correctly. So let me update this file here. So let me enable the line number. So below the name of the gateway, I need to add the host name. So it should be, the keyword is host names, and I am specifying the host name which I added in the /etc/host file. So master01.local. So this is the only change I need to did, But in production environment, you don't need to do those things because the DNS configuration is already been set and you already did this configuration when you first time created this particular routes. So let me save and exit. So now these routing rules will automatically apply when someone accesses the master01.local. So let me apply this. So kubectl apply -f colors-route.yml. So the HTTP route got configured. So kubectl get HTTPRoute. Now we can see the hostname is coming here. Earlier it was showing as blank. Just now we added the hostname. Now all the rules under the HTTP request will be applicable to this hostname. So when someone accesses this particular hostname, so all the rules which is inside this particular file will apply to this particular hostname now. Now let's test this over the HTTPS. First let's run the curl command against the HTTP only. So curl HTTP and the hostname which we just added, master01.local, and the NodePort, that is for this one. If I hit enter, it shows 404 because there is no root path set in the HTTP route. So let me give the path, that is /green. So it's working fine for HTTP. Now let's test the same with the HTTPS. So if I hit with HTTPS, so for that it's not working because the HTTPS is having the another port number, that is 31693. So let me update this. So here if I hit this particular node port along with the hostname, we are getting an error with the TLS certificate. Here we are using that self-signed certificate. To avoid that, we can simply use -k. So after curl, we can use -k. So this tells curl to ignore the trust warning since this is a self-signed certificate. So if I hit enter, now we can access the application with the HTTPS. And if I hit the another part, that is /blue, both the endpoints are working fine and HTTPS with the gateway is working perfectly. Let's quickly recap what we have done in this particular video. So first of all, we created a hostname in the /etc host file. So this is the hostname configuration we have added in the host file. Then we have created a self-signed certificate, that is certificate and the key using an OpenSSL command. Then we have created a secret which we use in the gateway. So this is the secret we just created. Then we have enabled the gateway to use the HTTPS. So for that we have added this block along with the certificate information we just created. Then we updated the HTTP route with a small change because earlier we didn't update anything regarding the hostname. So we have added this hostname here so that all these rules applies to this particular hostname as well. And the similar thing can be shown here when we run HTTP route. So the hostname will shows here. And at last we tested the HTTPS traffic through the gateway's node port. This is the cleanest and the most beginner friendly way to set up the TLS manually.
In the next video, we are going to automate everything using cert-manager. So there is no manual certificate, no renewals or no OpenSSL. Everything will be handled automatically. So make sure to subscribe to the channel and hit the bell icon so you don't miss the notification for the upcoming video. Thanks for watching. I will see you in the next one.